right? It's late at night, your desk is completely covered in papers, and the anxiety of a massive, looming final exam is just slowly creeping in. We have absolutely all been there. But what if that intimidating final exam was on the mathematics behind artificial intelligence? I know, it sounds terrifying. AI tools like ChatGPT and Midjourney are these massive, world-changing technologies, and honestly, the math behind them usually looks like an alien language. But seriously, take a deep breath. Today, I'm going to be your energetic, completely unintimidating personal tutor. We're going to demystify the math behind AI, breaking it down so clearly that you'll feel like a high school student acing a subject you used to completely dread. We're going to take all those complex symbols on the whiteboard and translate them into everyday concepts you already understand. Let's get into it. Okay, so here's our study guide syllabus for today's review. We've got 3 core units. Unit 1 is linear algebra, Unit 2 is calculus, and Unit 3 covers probability and statistics. And we'll wrap it all up with Section 4, passing the AI exam. Let's start crossing these off. Unit 1, linear algebra. Okay, so think of it this way. If AI were a massive, intricate cake we were trying to bake, linear algebra is simply the fundamental way we organize all of our ingredients. Because before you can bake, you need to measure the flour, the sugar, the eggs, and get them all lined up on the counter. Well, in the AI world, data is our ingredient. And our very first vocabulary word for that is vector. A vector is a mathematical object that has both a magnitude and a direction. Now, please do not panic at the fancy terminology here. A vector is really just a list of numbers. If an AI is trying to, say, recognize an image of a cat, it needs a list of features, right? The length of the whiskers, the color of the fur, the shape of the ears. That specific list of ingredients, that's a vector. To really wrap your head around a vector, imagine I tell you to just drive 50 miles. That's a scalar. It's just an amount, a single number. I mean, you could end up absolutely anywhere. But if I tell you to drive 50 miles north, boom, that's a vector. It gives you the amount, 50 miles, and the specific direction, north. In AI, giving the computer a specific direction is literally everything. Vectors act essentially as a highly specific shopping list of features, pointing the AI exactly where it needs to go, to understand a piece of data. So when we scale this up, if a vector is a single shopping list, a matrix is basically just a giant spreadsheet of those lists all stacked together. That's all a matrix is, a grid of numbers organizing lots of data at once. Now, on the other side of things, we have eigenvalues and eigenvectors. I know, it sounds like the hardest trick question on the test, but just think of them as the absolute core essence of that spreadsheet. If you were to somehow squish or stretch that spreadsheet, the eigenvalues are the structural beams that stay pointing in the exact same direction. And the eigenvalues just tell you how much they got stretched. They're basically the hidden defining characteristics of our data. Unit 2, calculus. All right, we've successfully organized our ingredients. Now, if linear algebra is how we organize the data, calculus is the engine that actually allows the AI to learn from that data. This is where the machine stops just holding numbers and starts actively improving itself. Our foundational concept here is the derivative. A derivative is simply the exact rate of change of a function at any given moment. Think of it exactly like glancing down at the speedometer in your car. It tells you how fast your speed is changing right at that exact millisecond. For an AI, derivatives are how it figures out if it's getting closer to the right answer or further away, and exactly how fast it's improving. It is the absolute foundation for the most important learning mechanism in artificial intelligence. To truly get how AI uses calculus to learn, I want you to imagine a blindfolded hiker. Seriously, picture it. You're dropped on the side of this massive, uneven mountain and you're wearing a blindfold. Your goal is to get to the very bottom of the valley, the absolute lowest point. Why? Because in AI, that lowest point represents 0 errors. You want to make the fewest mistakes possible, but you can't see. So how do you get down? Well, you use your feet. You feel the ground immediately around you to figure out which way slopes downward. So the crucial point here is how this physical analogy translates directly into AI math. Step 1. Our hiker feels the slope of the ground in different directions with their feet. In calculus, these are called partial derivatives. Step 2. The hiker figures out which direction slopes downward the sharpest and takes a step that way. That steepest path down, that's called the gradient. By just repeating this loop, feeling the slope, taking a step down the gradient, the AI slowly, relentlessly walks its way down the mountain. And finally, step 3 is reaching the bottom. When the ground flattens out, the AI has reached the lowest possible error point. It has successfully learned. Unit 3, probability and statistics. Okay, take a breath. We survived calculus. Now, if an AI has organized its data and learned how to minimize its errors, it still has to deal with the real world. And the real world is, well, messy and completely unpredictable.
So, AI uses statistics to make educated guesses and handle total uncertainty. Let's do a rapid-fire review of 3 core statistical concepts you definitely saw in high school. The mean is simply the average, the center of our data block. Think of it like the class average on a math test. The variance tells us how spread out those test scores are. Like, did everyone get a C, or did half the class get A's and the other half get F's? And standard deviation is just a standardized way to measure that average distance from the mean. These 3 simple concepts help the AI instantly understand the general shape, center, and spread of millions of data points at a single glance.
Next up is a probability distribution. You see, an AI rarely gives you an answer with 100% absolute certainty. Instead, it maps out all the possible answers and assigns a slice of probability to each one, based on how likely it is. When an AI model like ChatGPT predicts the very next word in a sentence, it's looking at these probabilities. A large slice means the AI is highly confident. A thin sliver means it's just a remote possibility. It's basically how the AI weighs its options before it speaks.
Now, what's really fascinating here is Bayes' theorem. The fundamental question is, how likely is X given that Y has happened? This isn't just some abstract equation. It is literally the mathematical formula for changing your mind. Imagine you think it's going to be sunny today, but then you look out the window and see these huge dark gray clouds. You instantly update your belief about the weather based on that new evidence. Well, Bayes' theorem is exactly how an AI mathematically updates its beliefs and predictions every single time it's fed brand new data. We wrap up Unit 3 with hypothesis testing. This is the ultimate reality check for an AI. The AI makes a hypothesis, a guess about the world. Then it looks at the cold, hard data. Based strictly on that statistical evidence, the AI decides if its initial guess was actually correct or if it needs to completely go back to the drawing board. It's basically the scientific method, automated and running at lightning speed.
Section 4. Passing the AI exam.
All right, pencils down. You've officially made it through the crash course. We've covered the core syllabus, and you now have the foundational knowledge of how these completely distinct branches of mathematics combine to create modern artificial intelligence. If you only remember one single thing from this entire review session, let it be this. Linear algebra holds the data, calculus learns from it, probability guesses the future. It's incredibly satisfying to see how flawlessly these 3 units interlock, isn't it? Linear algebra builds the spreadsheets and vectors to contain the world's information. Calculus acts as that blindfolded hiker, relentlessly stepping down the mountain to minimize errors and learn. And probability provides the framework to look at a messy, unpredictable world and make incredibly accurate, intelligent guesses about what comes next. You've aced the review. The mystery of those intimidating whiteboard symbols is gone. You understand the vectors, the gradients, and the distributions. And remember, these aren't just dry high school math concepts anymore. They are quite literally the building blocks of the future. So, I leave you with this final exciting thought. Now that you hold the mathematical keys to artificial intelligence, what will you build? Thank you so much for studying with me today, and keep exploring.